All right, so this is a question. You have radioactivity coming in your exams? No.
No, sir.
No, sir. All right. Okay. So this is a question from June 2022, paper 43, and this is question number 9. Please read the question carefully.
Figure 9.1 shows a magnet of magnetic of wire 10 to 0 Kelvin. The the magnet is pulled down. Describe in what happens.
Our Say, okay, so yes, read the question. Okay, so the question says that you describe and explain what happens with the needle of the sensitive center zero galvanometer. Um, can you give me your answer? It's 4 marks, right? What happens?
So the needle will move because as you're pulling the magnet down, it will
Okay. So actually, um, as the magnet is pulled down, what will happen? It will begin to oscillate. It will begin to oscillate, right? It will go up and down when you release it, and as it goes up and down, there will be a changing magnetic field linking the coil. Is
yes,
it? Yes. And this changing magnetic field that links the coil will result in what? Will result in an induced EMF. Will result in what? Result in an induced EMF, right? So we'll write our answer just like this. When the magnet is released, when the magnet is released, when the magnet is released, it will oscillate, it will oscillate, and a changing magnetic field. What? Changing magnetic field will link. Am I audible there? Will link the coil
yes,
in one direction. Linking, mentioning this will score you 1 mark, and mentioning this other point that it will link in one direction and then the other, and then the other, right? This will score you another mark. And then mentioning that this will induce, this will induce an EMF, and mention alternating EMF, alternating EMF in the coil, alternating EMF in the coil, right? So galvanometer needle deflects one direction and then the other. So needle deflects in one direction and then the other, right? Got
Yes,
it?
sir.
Yes, sir. All right. So, what is next?
The magnet is replaced state the effect of using a stronger magnet or what happens when needed.
All right. So, what will be the effect? Hmm? What will be the effect? Come on. No idea? Zen, am I audible there?
Yes, sir.
Yes, sir. Yeah, what will be the effect?
Use the strong yeah.
Sorry, say it again.
It will produce a strong
Yeah, it will. So, stronger magnet will produce what? Strong field. Both of these statements mean the same thing. What will be the effect of this?
the
And
needle
it
will deflect fast.
needle will deflect. Yeah, please say it. No problem if it's wrong. I'll correct you, na. So please say it.
So is the magnet moving or not?
Definitely yes. The magnet is moving, but you have replaced the magnet, na. You have replaced the magnet with another magnet. Now this new magnet is doing the same thing as the previous one was doing. But since it's stronger as compared to the previous one, what will this what will be the effect of this stronger magnet?
It will make the needle deflect faster.
Faster? No, it will make it deflect more. Maximum deflection, right? Not faster.
Yes.
It will, all right. Needle deflects, needle deflects more. Okay? All
Yes, sir.
right. Yes, sir. Then here's this question. A step up transformer is used to set up the voltage of a power station from step up the voltage of power station from 25,000 volts to 400,000 volts for a transmission along power line. Number of turns on the secondary coil is 3600. Calculate the number of turns in the primary coil, right? So you need to find the number of turns in the primary coil. You know number of turns in the secondary coil, right? And you know output voltage is what? Vs, voltage in the secondary coil.
Yes.
So is used to step up the output voltage of power station from 2500. So it's stepping it 25,000. It's stepping it up from what value? From 25,000, right? So this is the primary voltage, and it's stepping up to what value? 400,000. So this is the secondary voltage, right? And what was the formula for turns ratio?
So VP equals to
So NP upon NS or NS upon NP both means the same thing, is equals to VS upon VP, right? Hence NP is equals to VS upon VP into NS, right? So NP is equals to VS. What is VS? What is VS? 400,000. Is it?
yes.
Okay, and what's VP?
VP is 25,000.
25,000, right? Into what's NS?
36,000.
So please use your calculator to tell me the final answer.
576,000.
576,000. All right. So are the number of turns in the primary coil more or the secondary coil more?
Primary coil is more.
So I think this is something wrong, isn't it? Wait, there's one mistake that we did, and you did not remind me as well. In case you did not got catch of it, it's not VS, it's VP, because it's like this VP upon VS, right? It's VP upon VS,
Yes.
right? So it should be the other way around. That is, now please calculate it again.
2,250.
Come again.
2,250.
2250. 2250. Right. 2250. Can I write it as 2300?
Yeah.
All right. So 2300. All right. Sorry, Zain, can you tell me how I got an insight that my answer is wrong?
Because the number of turns in the pipe is more than second.
It doesn't link with the voltage, right? So you need to
Yeah.
take care of this. You need to be careful about such problems, right? Okay. Figure 8.1 shows a circuit. State the name of component X. This is what question? This is June 2022, paper 4-3. June 2022, paper 4-3, question number 80625 IGCSE. Alright, so the question says 8.1 shows a circuit. State the name of component X. Yeah, what's the name of this component X? Is light falling on it? So a
Yes.
component on which the light falls, what is that called? And its resistance changes based on the value of light. What is that component known to be? LDR, light dependent resistor. What is it? Light
Light
dependent
dependent
resistor. Light dependent resistor. Alright, potential difference across component Y is measured with a voltmeter. 8.1, draw the symbol for the voltmeter and its connection to the circuit. So potential difference is measured across what? Across Y. And we know that
resistance
when we need to measure the voltage, how do we connect the voltmeter?
parallel.
Parallel, right? So where do I connect the voltmeter? Somewhere here, somewhere here, right?
Yes.
All right. Okay. Now, the electromotive force of the battery is 12 volts. Component Y has a resistance of 400 ohms. EMF is given to you as 12 volts. Y has a resistance of 400. In a brightly lit room, the resistance of component X is 350 ohms. You need to calculate current in the circuit. What do you need to calculate? Current
in
in
the
the
circuit.
circuit. So what is the formula for current? Current is voltage
V
upon
by
resistance. Voltage upon, or total EMF upon
resistance.
resistance. So what's the
Yes,
voltage given to me? Voltage
12,
is given to me as 12, right? And what's the resistance?
400.
It, it's X is 350. X is 350 and Y is how much? 400 ohms, right?
Yeah,
And the, yeah, so what's the final value? 750 ohms.
750.
That makes it what?
That is 0.016.
0.016 amperes. 0.016 amperes, right? This is the current.
Yes,
0.016 amperes. PD across component Y. Now I need to calculate the voltage value of what? Of Y. Do I know the resistance of Y?
yes,
Alright. Do I know the current of Y?
yes.
What is it?
0.016.
Yes, because current stays the same in series, right? So in the whole circuit, it would be 0.016. All right. So that means I'll simply find the voltage. Voltage is current into resistance. Current is 0.016. Resistance is 350, sorry, 400. 400 ohms, right? So
Yes,
that makes the voltage what?
6.4.
6.4 volts. Unit is necessary to be written 6.4 volts. All right. 6.4 volts, right? Okay. Then in a dark room, resistance of component X is large. State the effect this will have on PD across Y. So component X is very large resistance. Component X is having very large resistance. What would be the effect of this on component, effect of PD across component Y? So here we are supplying fixed EMF, right? And since these two resistors are connected in series with one another, what will happen? These two devices are going to share the 12 volts, right? Share the 12 volts. Now what has happened? It's saying component X resistance has increased, right? So if I increase the resistance of component X, will the voltage drop across X increase? Will X be
Yes,
needing more voltage? Okay. So when the voltage of X increases, the total is 12, and that 12 is being divided. What will happen to the voltage across Y?
it will decrease.
It will decrease because the increase in voltage here is done from a portion of voltage of Y, right? So I'll just simply write that in a dark room, PD across component Y will decrease, right? So in a dark room, PD across component Y, component Y decrease. All right. Suggest a practical use of component X. Component X is an LDR, right? So where is it used?
So I can give any example.
All right, so it's used in security alarms. It's used in street lights to make them switch on and off automatically. In the daylight, the light shining on the LDR would be more, so that would indicate it that the street light should be switched off. And similarly, at night, the light shining on LDR would be less. That would cause the circuit to switch on the street light, right? So it's used to switch on and off street lights. Switch on and off, or you can say turn on and off street lights. All right, street lights. It can be used to turn on
So
security light. Sorry.
in a greenhouse,
Sorry, I did not understand what you are saying.
it can be used in a greenhouse.
Greenhouse.
Yes.
How?
So like if the sunlight is very high, like close of the circuit.
Okay, that it would not be very effective in that case, right? Because the light, sunlight is already almost the same. If you observe it the from 10 a.m. up towards 4 p.m. Almost the amount of light that's shining is the same. It's a different thing that its intensity is different. The heatness or coldness, the infrared radiations, that is different, right? But the LDR, it's just depending on the amount of light that's shining on it. So it would be more appropriate to turn on security light at nights. How would that be possible? Let's say if there's this door over here, right? And then there's this light shining from here, and then there's this receiver LDR present over here. Okay, so this light is continuously striking this LDR, right? And it is being registered. What happens if somehow this path is cut? This door is opened. What will happen? This light will be cut off, and the security buzzer will start to sound, right? So it's used in security alarms. It's used in security alarms. Okay, or you can say burglar alarms. Got it?
Yes, sir.
All right. Having done that, then there's this question from June 2022, paper 42. Again, 0625, IGCSE, June 2022, paper 42, question number 9. All right. And the question is, figure 9.1 shows a circuit with a 3-position switch. The moving part of the switch is always connected to point Y. One part is always connected to Y, around which it pivots. The other end of the moving part, labeled X, can be connected to one of the points A, B, or C. So this end can be connected either at A, at B, or at C. Okay. Now, the resistance of the motor is 2 ohms and the resistance of the resistor is 3 ohms. So motor, it's 2 ohms, and resistor, it's 3 ohms. Alright. Determine the current in the motor when the switch is connected to A. If I connect the switch to A, so how will the current flow? The current will begin to flow from here all the way like this, like this, like this, like this. Then, and this is how the circuit is going to be completed. Is it?
Sir, but it's not passing through A.
Come again?
It's not passing through A.
uh, Determine the current in the motor. Okay, it's not passing, na? Very good. So there's a gap, that means
Yes, so it's going to be open.
there's a gap, so the switch over here is going to be open. Very nicely identified. So what would happen? What would be the current then?
There would be no current.
No current, so I would write 0 amperes. Okay, If it's connected to point B, if it's connected to point B, now what will happen? There will be current, right? There will be current. Now when there is current in this loop, how many ohms of resistance is there? 2 ohms. And how much is the voltage? 12 volts.
Well,
So what is current? Current is voltage upon resistance. Current is voltage upon resistance.
yes,
Voltage is 12, resistance is. So what is the answer to this?
6.
6.0 amperes. If I connect this to C, that means now the current will flow in this way. It will begin from here all the way. No, not like that. It will now travel just like this. Begin from here, go like this, and
Yes,
then it will come out like this, right? So
yes.
now, what do you find? That this 3 ohms and 12 or 2 ohms, they are connected in series,
Yes.
right? So that means my total resistance is what? 2
5
ohms
ohms.
plus 3 ohms, that's 5 ohms. And what's the total voltage? It's 12. So current is voltage upon resistance. Voltage upon resistance. Voltage is 12. Voltage is 12, right? And this is
5.
5. So what's the current?
2.4.
2.4.
4.
2.4. 2.4. What's the unit?
Amperes.
Amperes. 2.4 amperes. Okay, two resistors of resistance 2 ohms and 3 ohms are connected in parallel. Calculate the combined resistance of the resistors in this arrangement.
So 1 over 2 plus 1 is 80 plus 7.
Alright, so I need to find what? I need to find the combined resistance of the resistors. Two resistors of 2 are connected in parallel. So 1 upon 2 plus 1 upon 2, or 1 upon 3.
Yes.
Alright. So, and did I tell you some trick for two resistors?
Yes, you multiply 3 and 2 and then
Alright, so that means the total resistance in parallel would be what? Product of resistors,
open the sum of
R1 into R2 upon R1 plus R2,
yep,
right? So that is 2 into 3
1.2.
upon 2 plus 3, that's 6 upon 5, that's 1.2. 1.2 ohms, right? Any problem, any confusion?
No, sir.
All right, going further. Okay, so this is the same year, June 2022, paper 42. June 2022, paper 42, and question number 8. Okay, the diagram show 8.1 shows how electromotive force of a 60 hertz alternating current power supply varies with time. Calculate the time period of alternating current. So you need to find the time period. Its frequency is given. What's the frequency?
60 hertz.
And so what's the formula for time period? Time is 1 upon frequency, right? Time period is 1 upon frequency. So time is 1 upon 60, right? That makes it what?
0.01.
0.017 seconds, right? Or I can write it down as 1.7 into 10 to the power of minus 2 seconds, right? So 1.7 into 10 to the power minus 2 seconds. I hope that's clear.
Yes, sir.
Figure 8.2 shows Figure 8.2 shows power supply connected in a circuit. State the name of component A. What's component A? Yes, then
That's a diode.
diode. All right. In each time period of the AC, 1.7, 1.5 10 per 17 electrons pass through the component A. Charge on an electron is 1.6. Calculate the average current in the circuit during one time period. You need to find current. You need to find current, right? And what's the formula for current? Current is charge upon time. Current is charge upon time,
Time.
right? Do I know the value of charge? Yes, it's 1.6 10 to the power minus 19 coulombs. Okay, minus 19 coulombs. All right, do I know the value of T?
No.
Uh, it says
Yes.
in one time period.
Yes. 1.5
1 point.
times 10 to.
That's the number of electrons.
No, sir.
In each time period.
Yes. Sorry.
All right, so what's the time period? No?
1.7 times.
Yes. So
Sir, from where?
1.7.
From when?
Where do I get that from? Okay, it has just
Oh,
told us.
you did significant figure.
Yeah,
Okay.
right?
Yes.
We just found it here, na? Shows electromotive force of 60 hertz. So electromotive force is basically resulting in current, right? And current is basically the alternating current. And what's the time period of the alternating current? This is it. Okay.
Yes.
Or if you would have not done that, okay, well, just tell me the answer to this first.
9.4 times 10 to the power negative 18.
9.4 times
10 to the power negative 18.
um mm, mm, mm. uh wait, there's some problem. 1.5 in each time period, then this is wrong. I have written this wrong. In one time period it says how many electrons pass, how many charges pass. 1.5, right?
Yes.
1.5 10 to the power 17 electrons, and one electron has a value of what? 1.6 10 to the power minus 19 coulombs, right? So it needs to be
Yes.
rephrased just like this. I'll have to multiply this 1.5 with,
1.6.
yeah, so that will make it
That would be.
1.5 multiplied by 10 power 17. All right,
Yes.
so that's what.
1.4 times 10 to the power negative
1.4 times 10 to the power.
4.
Okay, now you have done some mistake in calculating it. Please put the values correctly in brackets just like I have done. You see that this negative 19 and this plus 17 will make it negative 2 at the top in the numerator, right?
So 1.4.
That's correct. Now Now see, I'll just simplify this. Look here, this negative 19 and this 17, they together will make what? 10 power minus 2, right?
Yes.
And then you have this negative 10 power minus 2 here as well. So you would easily cancel them out, right? And the
Yes.
only answer would be 1.4 amperes. Okay. On 8.3, mark with an arrow labeled E the direction of electron flow through component B. Direction of electron flow through component B. So electrons flowing through B. Mark with an arrow I the direction of conventional current. Now, where does the conventional current flow from and where does the electron flow happens? Electron flow is negative to positive, and conventional current is positive to negative, right? Is it?
Yes.
All right. So you would find this is the positive side of the diode, this is the negative side of the diode. If conventional current has to flow, if conventional current has to flow, it has to flow this way, isn't it? It has to flow this way, positive to negative, right?
Yes.
And then if electron flow has to take place, it has to go from negative to positive, negative to positive, right? So electron flow would be the other way around. Okay. Now tell me one more thing.
Yes.
Which should I label I and which should I label E? The top arrow or the arrow below?
I should be the top arrow, and
I should be the top. I should be the top. I is what? Direction of current, conventional current. I should be the
yes,
top. Okay. And what about E?
E should be the bottom one.
All right. Good. Show the circuit with with components B and C connected to a direct current DC power supply of EMF 12 volts. The current in the circuit is 0.35 amperes. Calculate the power delivered by the supply. So supply is how many volts? 12 volts. How much current is flowing? 0.35 amperes. So what is the formula
0.5
for power?
IV.
IV. Can I find power easily?
Yes.
All right. So please tell me the
4.2.
answer. Sorry?
4.2.
4.2.
Sir, if this
4.2.
is the IGCSE exam, it
Come again?
should be a star.
Sorry, your voice cut off.
Sir, if the IGCSE exam is easy, it should be an A star. Inshallah.
Mm, your voice cuts off in the middle. Your IGCSE exam, what? I have heard it till that point.
Sir, if the IGCSE exam is easy,
No, I don't know. I hear your word very clearly, IGCSE, and then it goes off.
if the IGCSE exam is this easy,
Yeah,
it should be a star.
inshallah, inshallah. So you
Inshallah.
would have seen I have made you do questions much more harder than this, isn't it?
Yes.
And I have made you practice those questions from 5054. All right, and that papers are compiled from 2000 from 2000 till 2020. including all variants. So when you do those questions, then these just look like a piece of cake, isn't it?
Sir, what score is 5054?
It's parallel to this sister board of IGCSE. It's GCE, right? It's O level. This is the paper that students give in Pakistan. Students give IGCSE too, right? But students in Pakistan mostly appear for GCE, which has a code 5054.
Okay.
Got it? And thanks to God that you did not know about this code previously, because at times when I practice with my students papers from 5054 and they know that this is not the IGCSE code, they ask, sir, why you are not making us do questions of our board? So, see, this is why, this is the reason you find these questions so easy now. All right, so uh, I would want you to do some questions like note down this June 2022, paper 4-2, question number 7. June 2022, paper 4-2, question number 7. Done?
Yeah.
And then June 2021, paper 4-3, paper 4-3, question number 9. Okay?
Yes, sir.
And also question number 8, A and B. Do not do C because that's not part of the syllabus now. 8A and B.
Yes, sir.
Right? And just last one, June 2021,
Yes.
paper 4-2,
Yes.
question 8, 9, and 10.
Okay,
Alright?
sir.
So try these before the next class and we'll continue from there. So I hope the class went well today. I don't know that other day that glitch was so bad. All right. So are we done? Is our time over?
Yes, sir.
Okay. So we'll keep it till here. See you in the next class. Until then, take care. Allah Hafiz.
Allah Hafiz. Assalamu alaikum.
Alaikum assalam.